Okay, so for this lesson, we are going to be, or this unit, we're working on linear and exponential functions, and these are our focus area notes. Before we went on break, we started talking about ways of finding slope. So here is my slope man, and I use this. Typically, this picture is in my brain when I am trying to figure out if this slope is a positive, a negative, a zero, or undefined. And I use this picture to help me out. So this face, all right, we have 4 different parts. We have our left eye, which is the positive eye. Okay, so I have this positive eye up here, and the line or his eyebrow is going up. It's going from the bottom left to the top right, and that's the way it's moving. So if your line looks like this, it means it's a positive slope. If it is going from the top left to the bottom right, that means we have a negative slope. Okay, so this eye over here is your negative slope. All right, so then now we move to the nose. And if your line is going vertical up and down, this U underneath, creating the nose, means that your slope is undefined. It means you cannot find the slope of a vertical line. If your line is horizontal, which is the mouth, and we have the little circles for the dimples on the sides of each of the mouth, and those are symbolizing 0. So if you have a horizontal line making the mouth, that means your slope is 0. Okay, so just a little fun little visual to help you remember how to identify slopes. Okay. Now we're going to get into some of the vocabulary that we're going to be seeing in this unit. Remember, vocabulary is very important because it allows us to understand what we are talking about, or what I'm talking about when we're discussing the unit notes. Okay, so make sure you get these terms in your head and understand what they mean. So the first term is linear function. When we're talking about a linear function, it means it's a function whose graph is a straight line. Okay. And again, think of the word line, that the word line is right in the word linear. So it means it's a straight line. The equation will not contain exponents. It won't contain square roots of fractions with an x in the denominator. Okay. So if your equation has those two qualities in them, then you know it's not going to be a linear function. Our next term is your x-intercept. We've talked about this in the last unit. We touched base on x and y intercepts. And what it's saying is it's a point where the graph intercepts or crosses the x-axis. And we know your x-axis is the line that is horizontal on the graph. So when it's crossing that line, right there is where your x-intercept is. Okay, that's where it's crossing your x-axis. And if you're looking at a table and it says, what's the x-intercept? You're going to find the point where your y coordinate is 0. Okay, so you will never have an x-intercept that crosses the y-axis because your y-axis is going to be 0. So like this point might be where your x is 3, and it's not going up or down on the line. It's staying right on your x-axis. So that means your y is always going to be 0. Same but opposite is true for your y-intercept. It's the point where the graph intercepts or crosses the y-axis. So we have our y-axis, which goes up and down, and the line crosses that right there. And that might be, say, y is 3, and that means that your x-coordinate is always going to be 0. All right. And now slope. Again, we've talked about slope before break. So that means it's the number that you get, and that's representing the steepness of your line. All right, and we just went over that it can be positive, it can be negative, it can be 0. Okay, so when it's positive, it's going up to the right. Okay, so it's going up to the right. A negative slope is going down to the right. So again, that's going down to the right. Right, so up to the right, down to the right. Slopes that are flat, right? They're flat. That makes our mouth. That we have a 0 slope. 0 slopes give us a flat line. Okay. Now we're getting into a few formulas that we're going to see during this unit, and they all have to do with slope. So we have AX standard form. If they're talking about, anytime they're talking about standard form, we are looking at this equation here. AX plus BY equals C. A, B, and C are real numbers. B is not 0. So for instance, if you had this standard form 3x plus 2y equals 10, that means that your 3 is an A, your 2 is a B, and your 10 is a C. Okay, so we're just identifying what those variables are. The next equation we have is slope-intercept form. Okay, so if they ask you to put something in slope-intercept form, they might ask you to take the standard form and turn it into slope-intercept form. And that just means that your y is equal to mx plus b. So that's something that you want to keep repeating to yourself, y equals mx plus b, to find slope-intercept form. And in that equation, your m is your slope, and your b is your y-intercept. And we just talked about y-intercept on the previous page. So that means your b is where your line crosses the y-axis. All right, so if your equation was y equals 1/2 x plus 2, that means to graph this, you would start at 2 on your y-axis. All right, so that's where it crosses the y-axis. Next, we have point slope form. This is where you have y minus y1 equals m times x minus x1. So if they give you your slope, m equals 1/2, and you have a point of, say, 2, 4, you can place these variables, x and y, into your equation right here, and your slope into your equation right here. And you can find your point slope form, and that would be it. So it would be y minus 4 equals 1/2 times x minus 2. And that would be it for your point slope form. And next we have slope formula, which we already did before break. M equals y2 minus y1 over x2 minus x1. Okay. Now we have working with recognizing linear functions. Here we have a linear line, and we can see to find the equation of a linear line, we're using your slope formula, which is your change in y, y2 minus y1, over your change in x, x2 minus x1. And that's your slope. That's how you recognize a linear function. It is always constant. It's never going to change. So if it does change, your line would not be straight, because that means your slope is changing somewhere in there. Instead of going, for this slope, we have 1/2. 2 over 4 is 1/2. Instead of going up 2 over 4, or we could say up 1 over 2, right, if for 1/2. Instead of saying that, if it changed somewhere, like say the next time it was like up here and then here, and that was your next point, that means my line is like going this way, and that's not what we want. That means our line is not linear. So your linear line is always going to have a constant slope. Okay. We look at this example over here with the table. There's a constant change in your x values. It's always increasing by 1. But then when I look at my y values, I have it increased by 3, it increased by 5, then 7, then 9. So that's not consistent, right? So that means it's non-linear. We can still graph this, but it's not going to be a straight line. So it's not linear. Here's another example. We have y equals 3 to an exponent of x. So what that means is I take all my x values and then I plug that in my equation. And one thing you need to remember when we're talking about exponents that have a negative value is to remember your exponent rules of putting negative exponents in the denominator to make it positive. So when we do 3 to the negative 4 power, what that really means is 1 over 3 to the 4th. Okay, and so that gives us a fraction of 1 over 81. So then I would do that right here. 3 to the negative 3rd is going to give us 1 over 3 to the 3rd, which is equal to 1 over 3 times 3 is 9. 9 times 3 is 27. So this would be 1 over 27. Then we have negative 2, which gives us 1 over 9. And then we have 1 over 3 to the 1st power, which gives us 1/3. Next, we have 0 is 1. And then we get into the positive. So now I don't have to put anything into a fraction because they're positive, and I just solve for the exponent. So 3 to the power of 1 is just 3. And then these are done for us. 3 to the power of 4 is 81. So now let's look at the graph. All right, so you notice that this graph has this straight line here, right? It's actually not touching the x-axis here. It's very, very close to it, but it's not touching it. So when it's -4, it is 1 over 81 units up on the y-axis. So that's very, very close to 0, but it is not 0. So you'll never get a point when a graph looks like this where you'll have 0, 0, or let's see. Yeah, it's never touching the x-axis. Okay. So here it starts going up and up very slowly, and then all of a sudden it just shoots up. All right, so we're only at 6 here, and it shoots up, and it's somewhere in the hundred, like the high hundreds, because already right here is 500. Okay, so with exponents, you're going to find that your y value is shooting up very quickly. It goes slow, but then it goes very quickly with exponents. Let's get into objective 1, where you're finding the slope or the rate of change in linear relationships. So again, we did practice this before break. So we're just going to do a few more practicing. We have this table, and our x values are given below, and your y values are given. So when you have a table like this, these points are actually creating coordinates, okay? And that can be used to help you find the slope. We also have an option where we look at the rate of change of our x. So -5 to 5 is +10. And then we say 5 to 15, that's another 10. And 15 to 25 is another 10. So it's consistent. On your y values, we're seeing that it is a constant change of -5. So I can look at this and say my slope is -5 over 10. Okay, so that's looking at it from a table point of view when you have all of these points already for you. So when you're finding the difference from 2 to -3, you're really doing what we did over here and what we did before break. You're subtracting the second y from the first y, or the first from the second, and you're getting -5. And when you go from -3 to -8, you're getting -5. So you're finding that the rate of change, which is right here in your y, is -5. And your rate of change in your x, which is what we did here, is 10. So when you see that, you can take your y over your 10 to find your slope, which is -1/2. Okay. So what we can do is try some examples down here. We have, we'll start down here. So I'm going to say x1, y1, x2, y2, and I do my formula. 20 minus 12 over -3 minus 7. Okay, so what is 20 minus 12? That is 18. No, that is not 18. What am I doing? Hold on, let me try to. That is 8 over a negative minus 7, -3 minus 7. So what that's saying is -3 plus -7. All right, so that would be -10. So you got to, again, think of your sign rules, positives and negatives. So this is really, let's simplify this to for -4/5. That would be your slope. Okay, now let's look at the next one. I'm going to just do 1, 1, 1, 2, 2. I know the second number is y. So -8 minus 2 over 15 minus -5. This gives me -10 over a negative times a negative is a positive, right? So that would give me 20, which simplifies to -1/2. All right. So that is the end of objective 1. You are going to click on this box and work on your check for understanding just to see how you're doing with finding slope.